Hi there, class. It's just me, Mr. Wee. I just kind of want to go over with you this before I start. Please make sure you have a graphing calculator or you have access to a graphing calculator. If you don't, you can try to check one out at our library, but I don't know if we have any more. Otherwise, you need to get one for this year. It just makes everything a lot easier. Okay, so please go ahead and get your graphing calculator. This lesson's you're going to be really required to really use one and see what's going on, okay? To see what's happening, all right? So here's what I'm going to do. This is what the graphing calculator looks like on the left. Definitely follow my, let me see if I have my tools here. Sorry. Give me 1 second here. So just follow my mouse cursor, and then like wherever it goes to hit the buttons, okay? Make sure you follow that. And you can kind of see that it kind of clicks. As I click on a button, it flashes, like it kind of blinks black and white, black and white, black and white, okay? And then clear. So just make sure you follow the mouse cursor whenever I go to the graphing calculator, because that's essentially what buttons you're going to have to press wherever my mouse cursor hits. Okay, so you should have this handout as well, right? I guess I'll post a link to this this handout for the notes. But let me see if I can kind of zoom in a sec, just a bit, okay? Here, all right. Okay, so let me zoom out a little bit here. Here we are. Okay, so this was meant to be a exercise. This is the graph of ax squared plus bx plus c looks like this. This is what we call a parabola, okay? Notice some features about it. It's a U shape. It's very symmetrical, meaning if you cut it right down the middle, both of the sides look like they're pretty equal in the way that their shape looks. You are required to fill in the blank from this word bank. So I know it's kind of hard to see, but let me see if I can just zoom out really quick. It's just normal resolution here. Okay, so again, I really implore that you have this printout. You have this printout printed out. Yeah, parent function, axis symmetry, vertex, x-intercepts, and y-intercepts, and if you fill in the blanks, this is what you should have gotten. Let me see if I can kind of zoom in on this. Okay, so this is the vertex. If you read the definition, the vertex is the minimum or maximum point of a quadratic function or equation. So this would be the smallest point. This is the minimum point. This is the lowest point on this graph. So that is, by definition, the vertex. And then wherever the graph crosses the y-intercept is literally called the y-intercept. Wherever the graph crosses the x-intercept, okay, that would be the x-intercept. And then what's unique about this next thing that I'm going to bring up is it hits the vertex. This is called the axis of symmetry. Remember how I told you both sides look symmetrical if I cut it in half? Well, that thing that cuts it in half that hits the vertex is what's called the axis of symmetry. Sorry, that's an S there, okay? That's an S. The axis of symmetry, right? Read the definitions there to understand, and then we're going to kind of go through here. And we're going to use our graphing calculator very soon, so prepare to kind of learn a little bit from this, okay? So this is if I graphed, so this is I didn't want you to do this by hand, but in fact, at 2.3, it's going to ask you to graph quite a bit. So I implore that you use your graphing calculator to save a lot of time to get through 2-3. Use a table of values to graph y is equal to x squared, and then state the range and domain. Okay, so here I have a t-table. Use a table. I made a table where I put in some x coordinates, -4, -3, -2, -1, 0, 1, 2, 3, 4. You'll see why I kind of did it like that, where I have like the same negative numbers here. After 0, I put them in as positive numbers. Because you kind of see a weird feature about it. If I plug in each of my x values into the equation, y is equal to x squared, like in this one here, I did -4 squared, I got 16, -3 squared is 9. if you keep going down the line, look, it's like 16, 9, 4, 1, 0, and then after the 0, it repeats 1, 4, 9, 16. It's because it's being squared. When you square things, even if it's the negative version of the same number, 4 and negative 4, you'll end up getting the same exact positive number, okay? And that's why we get this weird U shape, this parabola, okay? And I'll ask you, so this is what it looks like when it's graphed, fully graphed out, okay? Like negative 4 comma 16 is the first point here. Negative 4 comma 16. So that's negative 4 comma 16. Over here would be 4 comma 16. You can kind of see like they're kind of like being mirror images here. And then this is going to be negative 3 comma 9. And this is this is positive 3 comma 9. And this is negative 2 comma 4. And this is 2 comma 4, okay? So I graph this out and you see this U shape, and then I ask you what the vertex is. Well, it's right at the lowest point of the graph. It's 0, 0, and then I ask you what the axis of symmetry is. It's this line here, but you have to remember though, if I ask you for a line, it's not just a 0 comma 0. You have to write it as an x is equal to something. In this case, my x value, if you think about it, see, my x value is equal to 0. That means this line's equation is x is equal to 0. Because at any y value, y equals 1, y equals 2, y equals 3, y equals 4, y equals 5. At any y value here, x is always equal to 0. That's why this line is x is equal to 0. Okay? All right. So normally, you would have to do this all by hand. And the reason why I have this in notes for you is because I don't want to spend like, this could easily take like 15 minutes to do this on your own time and on my time, okay? So that would take a lot of time for you to watch this video, but let's save some time and show you how I did it here. So before you do anything, okay, as long as you don't have anything saved on here, like any fancy programs, the first thing you want to do is go second, and then you see this arrow button. That means you're in the second mode. You're going to go over here to this plus sign where it says MEM, short for memory or mem. You're going to go here, and then go down to press this button to go down to reset, this arrow down key, or you can press the number 7 because 7's right next to reset, and then you're going to press either enter or the number 7. So I'm going to press enter, and then I'm going to basically reset all RAM. So go ahead and just press enter again. And then it's going to ask you, are you sure you want to reset? And then you're going to go press down. And you're going to say, yes, I want to reset to number 2. Or you can press number 2 like this. And there you go. RAM is cleared. The reason why we do that is just because if you have any errors in graphing, this kind of restricts any errors from happening. Okay? Because sometimes it'll be, it can't graph. It's like, oh, I don't know what I'm doing wrong. Okay, anyways, let's check this out. Let's go to y is equal to, and let's put in x squared. I know it looks weird, but you see an x here, you see an x here, then you see another x here. The x that we want to use, is this right here. Underneath the button mode is xt, it looks like a 0 and an n. Press that button. That's the x button, okay? And then you're going to square it. So you have two choices. Either you can press this to square, or go back, and then you can delete it with this button here, delete. Okay, let's see. Whoops, I don't think it. Okay, X, you can press this key called a caret, and that's to the power of, and you can put any number you want. In the future, you can put 5, 6, 7, 8, 9. That's why this button only has to the power of 2. But you can also manually enter in like that with this key. It's called the caret key, okay? And that's it. You're going to press enter, and then you're going to press this magical button called graph. And let's see what happens. Whoa, look at that. It's the exact same graph as what I have here on the right-hand side of your screen. Now, let's say that I don't. So here's some features that you want to check. Oh, one more thing. I'm sorry. Under graph is, in blue, table. Meaning this table, if you pay attention, this table that I did by hand, I had to solve each one by hand. I could save time, and I don't have to do that. Let's go to second, because you notice that is in blue, the lettering is in blue. So that means you want to press the blue second key, and now you can activate the table command. There you go. And if you go up and down, look at what we have here. If you think about it, that's my column for x values and my column for y values, just like my table over here, it gives you all the values. -4, if you plug in -4 as x, your y value should be 16. -3 should be 9, -2 should be 4, -1 should be 1, 0 should be 0, 1 should be 1, 2 should be 4. You can keep going down. Look at all the values. Look at that. That's awesome, isn't it? So when you're graphing in your homework for any of these problems, you can just use this table to save some time. I'll show you like an example in a second, okay? So let's actually do that really quick. Clear to get out, okay? So let's try this. Y is equal to x squared minus or plus 3, okay? And I want to, so on the bottom you want to make some notes. I want to make a table, xy table, and I want to graph. So let me show you how you do that. So my graphs are usually quick and simple. I don't use graph paper, but I use just equally spaced lines. I do about like 5 to 6, if I can, or I do about like 8 on each side, like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I label this the x-axis and this is the y-axis. That's it. Okay. That's how I set up my axis. It's really quick and simple. Okay. Obviously, mine isn't perfect. I don't use a ruler to do it, but hey, I did a pretty good job doing that by eye. So I'm going to go back to your calculator on the left-hand side of the screen. Okay. Let's go to the y is equal to, and then let's clear this. Let's put in a new equation. X. I'm going to use that caret sign. I like doing this one to get in the habit of using this guy because you have more options with what power you want to put in. But I'm going to put 2. And then I'm going to say, and to get out of here, because you notice that the arrow is still up in the exponent, see if I press plus, it's going to stay up there. Okay, so I made a mistake. Let's go back, delete it. I want to get out of the, oops, yeah, I'm going to delete that. Okay, I'm going to get out of here by pressing the right key. So it goes back down. Okay, so now it's back down to the regular level. I'm going to play plus 3. Okay, and let's graph it and let's see what happens. Oh, it kind of moved up if you think about it. Let's go to second table and let's write in some new values. I'm going to try, it looks like these y values are really big and it's not going to fit on my graph, but hey, let's just put it down anyways, okay? So let's expand this really quick. Oh, nope, I need to see that. I don't know if you can see, but I'm going to copy it down. So that's -4, 19, -3, 12, -2, 7, -1 is 4, 0 is 3. Let's continue down. So you see how much time this saves instead of having to, normally I would have to, let's go down here. Normally on here, so now look where my finger's pointing. Normally I have to do this by hand. -4, I put it in the equation. That's -4 squared. That's 16 plus 3. That's 19. And I have to write that. And I have to show all the work. But here, if you use your graphing calculator, you don't have to do any of that. So let's see. 1, 2, 3, 4. Let's graph all this stuff. 1 is 4. 2 is 7. 3 is 12. And then 4 is 19. Okay? Now let's graph that. I can't graph a lot of these points. So let's just start from the middle. 0, 3. That's 0, 3. You don't have to actually label the points, but you can if you want. 1, 4, it's going to be right here. -1, 4 is going to be right here. And then 2, 7, I think, let's see, 1, 2, 3, 4, 5, 6, 7. 3, 7 is going to be right here. And then, or that's -3, 7. That's -3, 7, just so you can see. I know it's really hard to see, but that's -3, 7. That's 0, 3. These are just reference points to show you where my points are. Like, that's why I wrote them down. You don't have to write them down. And then go down to here, 3, 7. Just to remind myself, like, what these values are. And then now let's connect the dots. I think that's good enough. It's not perfect, but you get the idea, all right? That's not too bad, okay? And then the vertex is the lowest point. So this is the vertex. My vertex is 0, 3, okay? It's right there. So I'm going to say that's my vertex. And then the axis of symmetry is going to be the line that hits the vertex and goes in the middle. And if you think about it, it's not x equals 1. It's not x equals 2. It's not x equals 3. It's x equals 0. So that's my axis of symmetry. That's my axis right there, okay? This is my axis of symmetry. That's how I'd graph that, okay? Now, one other key feature. So let's go back to my calculator here. Now, one feature is maybe I want to see what it looks like from up here. I can go in, I can zoom, I can go out, I can say, I can go down. So again, I press this zoom button here, and I go down to zoom out, or you can press the number 3, and then every time I press enter, it goes out, okay? But let's just say that this is way too narrow, and I want to see like a better, I don't know, I want to see a close-up version of this, okay? And I'll try to zoom in, right? That's number 2, and let's try that a few times. Every time you press number 2, it zooms in, okay? So I press it again. All right, now I'm zoomed in too much. So let's go back. Let's reset. If you go down to zoom standard or number 6, okay, it'll just reset back to where it started. Here's what I can do. I can actually go to the window. And if you can kind of see here, right, I know it's kind of hard to understand, but what these values are is like, imagine, so let's look at my graph here on your right-hand side here, right? This is sort of like a window, right? What this is saying, now look back on the calculator, when it says x min is equal to -10, now go back on the picture to your right here, what this means is on the window that you see in your graphing calculator, the x min, the minimum value of the x, is going to be -10. So your window is going to expand out to where your x-axis is going to have -10, and then go back to your right over here, okay, or left, I'm sorry, go back to your left on the calculator when it says x max. That means, go back to the picture here, x max, the right-hand side is going to go all the way to -10, okay? That's your small window. And then, let's say that my y, so on my graph, the lowest y value on the y-axis is -10. If you go to my left here, then it says y minimum is -10, and the max value for your x or your y-axis is 10. So it only goes up to 10. The scales mean that if you go back on my graph, you guys knew that I went by each increment is 1, 2, 3, 4, 5. It goes up by ones, okay? That's what this scale is for. So if you look at, so arrow down here on the calculator now, okay, we're on the calculator now, where it says x scale, okay? That's what each increment goes by. 1, 2, 3, 4, 5. Sometimes you can go by 2s, okay, or you can go by 3. It doesn't really matter. You can set it to whatever you want, but I have my graph going up by 1. Same thing with the y-axis, okay? On the y-axis, I'm going up by 1, 2. It's all going up by 1 unit each time. I could change that and say that each unit goes up by 2, however you want. So let's adjust this, though, okay? Now, let's say that I want to make my window smaller, okay? I want to make my window smaller, so I only see the parabola here. Let's maybe change this to like -5. Let's play around with this. And 5. Let's see what happens. Let's graph it now. Whoa, you can kind of see it kind of closed in. It kind of made, it kind of shortened the window down a little bit, right? So now I'm only seeing a little bit less now, but it's kind of nice. It kind of cuts out a lot of dead air, right? So I only see the parabola now. Let's go back. I'm sorry, let's go back to where it says window right here, okay? And let's say that my y values, let's take a look at my window here. Do I really need to see what's on the bottom here? There's no part of the parabola that hits the bottom of the graph. So let's exclude that altogether, and let's say that let's just keep my window like this, and let's say that the smallest y value is 0. 0 right here, 0, meaning you only look up here. So let's try that, 0. And let's say my max value goes all the way up. The window goes all the way up to like 20, okay? And the scale I can just keep the same. So look at that. See, now it cut off the bottom of the x-axis or the y-axis, and then now I see way more of the graph, okay? And if let's say that I've graphed something else, so you don't have to do this part. So let's say I graph x to the 3rd just to see what it looks like, and I press enter and I graph. Okay, well, it's actually pretty good, but let's say I want to see if there's anything on the bottom now, okay? You can go back to zoom and you can reset the whole thing just to make sure. Oh, so that's good that I zoomed out, or I zoomed back the way it was, because now I do see that there's a lower part of the graph. So those are the things I want you to learn from the graph, okay? I'm almost done, so I still have some other stuff. Well, actually, I'm not almost done. There's still more to this section here, but let's go back on my graph and let's just press clear and let's just keep this reset. And let's go here. Let's focus on here for just a bit, okay? Here are some notes I want you to fill out. All right. The parent function, x squared. So we're looking at all graphs that have x squared, whether it's x squared plus 2 or 2x squared plus 3x plus 2. The thing is, the parent graph that we're looking at is just x squared. Okay, we're looking at anything that has x squared in it. It'll always give me this u shape. That's basically what I wanted to why it's called the parent function. We're going to look at a bunch of different u's that might do different things, okay? Standard form is how all the equations are written. Ax squared plus bx plus c. Okay, I'm going to give you a, so let me give you an example. Y is equal to 2x squared plus 2x plus 3. Your a would be equal to 2. Your b would be equal to 2 because it's, so a is in front of the x squared. So my a is equal to x squared. B is equal to 2 here, okay, because it's, your b is also in front of an x. And then c is just a constant, and my c is 3, okay? That's not bad. What about this? Y is equal to 2x squared plus 2. Well, I don't have a b, but I do have an a. A is equal to 2. B, because if b is not there, you have to give it at least a value, so b is equal to 0. Then c would still be 3. How about y is equal to x squared just by itself, okay? Well, a is technically 1, because if a can't be 0, because if 0 is there, then the x squared wouldn't be there. It'd be 0 times x squared. There'd be nothing there. So a is equal to 1, b is equal to 0, and c is equal to 0, okay? So those are 3 situations, okay? So all these equations are written in this format. Y is equal to ax squared plus bx plus c. The type of graph, that u shape, is called a parabola. And what's very handy about this standard form is that these letters can help us figure out stuff. Let's say that I don't have the option to graph. I don't have time to graph like a t-table and stuff. I can use this guy. I'm about to show you is you can use this equation to find out a whole bunch of stuff about your graph. The c, if you put it into a coordinate, will end up being your y-intercept. 0, c is your y-intercept. Okay, again, a y-intercept is like wherever the graph crosses the y-axis, right? If you look at your c value, that ends up being the coordinate. So I know it's hard to see, but look, if you can kind of look here, there's the axis here. Your parabola crosses the y-axis at 0, c. I know it's, let's see if I can kind of focus on it, okay? The parabola crosses the y-axis at 0, c, okay? Now, if you take the b, so write this down too. You might not understand this last one, so don't worry about it, right? I'll show you how to do that, but just write that down for now. But this is where this is the last real place I'm really going to talk about before I show you an example. X is equal to negative b over 2a. If you take your b and you take the negative of it, you divide it by 2 times your whatever your a value is, you get the axis of symmetry. Again, as a reminder, if you forget what that means, x-axis, y-axis, that means that line that kind of makes that mirror. Remember, like when I make that parabola, and I make whatever that center mirror line right there is, that's your axis of symmetry. To find that equation, that is, you take the negative b and you divide it by 2a, okay? In the vertex, I'll show you how to do that, okay? So write this down. This is your first example. So go ahead and write identifying characteristics from functions, and then here's your equation you're given. This is an example problem. F of x is equal to 3x squared minus 6x plus 2. You identify your a, your b, and your c. So my a is 3 in front of my x squared, okay? If you look here and here, okay? My index finger is showing you that ax squared, a should be in front of x squared. So your a is 3. B is negative 6. And then c is equal to positive 2, okay? What are we going to do from these? So to figure out the axis of symmetry, remember, I just told you to do x is equal to negative b over 2a. So I took in negative, so I take in b, which is negative 6, and I put in the negative sign in front of it because it's negative b, but b is already negative 6. So b is negative 6, but if I take the negative of that, it's negative 6 over 2 times a. My a is 3, so it's 2 times 3. I get negative 6 is positive 6, and then 2 times 3 is 6. So my axis of symmetry is equal to 1. So what that's going to look like, if you can imagine, I don't know where my vertex is going to be, but I just know that at x equals 1, okay, so this is the x value of 1 on the x-axis. I know that x equals 1, okay, at x equals 1, there's going to be a line at x equals 1 that the parabola is going to mirror itself over x equals 1, okay? To find the vertex, so what this is that this is an x comma y coordinate. What you're supposed to do is you're supposed to take your axis of symmetry as your x coordinate and then plug it into the y value and get a y value. What are you talking about? Okay, so let's go back a second, okay? I have my x value as x equals 1, okay? X equals 1, and then I plug it back into the equation. So basically, you can write this down. Go ahead and write this down, but basically, I know this looks weird. Y is equal to f of x. Y is equal to f of negative b over 2a. You're probably not going to have to do that in the future. All that really means is you're going to plug in x equals 1 back into this equation up here. Whatever your f of x or your y is equal to. Your y is equal to that, okay? Y is equal to 3x squared minus 6x plus 2. Or you might see as f of x is equal to 3x squared minus 6x plus 2. This means the same thing for now, okay? So you're going to plug in x equals 1 back into the equation. Remember how it's 3x squared minus 6x plus 2? You're going to plug in 1 into that x. So it's 3 times 1 squared minus 6 times 1, because it's 6x plus 2, okay? So that's going to be 3 minus 6 plus 2, and then you get negative 1. That is the y, so that's y is equal to negative 1. X is equal to 1. That's going to give me a coordinate, an x comma y coordinate of 1 comma negative 1. That is the vertex. Okay, so to go back on our parabola now, the way it looks now is that the axis of symmetry is still at x equals 1, right? And our vertex is now confirmed to be 1 comma negative 1, the lowest. So remember how before I just put the axis of symmetry, but I didn't know where the vertex was? Now I know exactly where it is. Okay, so I'll just draw the U shape now. The last part is the y-intercept. All you have to do is put in your c. It's really simple. You just put in 0, comma, whatever your c value is. And in this case, my c value was 2. So that's what my y-intercept is going to be, 0, comma 2. And if you look very closely, I was very diligent. This was all premeditated and planned, but this y-intercept is now 0, comma 2. So I have 3 elements, this, and this. That's all you really need. You don't need a t-table to graph this. As long as you can figure out your axis of symmetry, your vertex, your y-intercept, you can graph this guy out with just those 3 things, and you're done. That's it. That's all you have to do for graphing for 2-3. Okay, that's 2-1. I'm sorry, 2-1. Okay, and I guess that's it. So, I guess that's all you guys got to do. So that's all you have to know now for this section. I believe I have one more video, just one more video that I'm going to upload, but it's not going to be by me. It's how how you can shift this parabola up and down and left and right. Okay, you guys will have to watch that video after this. Okay, guys have a great day.